Good morning, guys. Welcome back. So, in today's lesson, we're going to go ahead and do 11.5. And I'm going to have you guys actually go on to this website called joinpd.com. This is where I'm going to have the PowerPoint lesson for you guys. So, I'm going to just wait and just give you guys 1 minute to go ahead and log on. And then that code is the PIPQE. And then obviously you can enter with your any email address. It's going to ask you how you're feeling today. And then I'm connected, and so I'm just going to go ahead and start. And then this is pretty much what I would have done with you guys. Okay. So how was the homework assignment? Go ahead and drag the dot to either the thumbs up or the thumbs down. And then I can obviously see on my end how we're doing depending on where the blue circles are. Okay, so then today we're going to go ahead and do 11.5 volumes of prisms and cylinders, and the goal is to find volumes of prisms and cylinders, use the formula for density, and then use the volumes for prisms and cylinders. So the very first thing that we're going to be looking at is we have this formula for a prism, and it is base times the height. And so base is obviously the bottom part of this solid figure, and then the height is just, the altitude or how tall something is. And so these are just some different examples for each. Just the formula is still the same. It's base times height. However, it's really good to be able to see just how different the shapes are. For example, this triangular prism looks different from the rectangular prism, which looks different from the pentagonal prism, which is obviously different from the hexagonal prism. But one thing that I do want to mention is that a prism, one of the unique qualities of this is that the sides are formed by rectangles, and then obviously we get the name by the base. So in this case, the base, it's formed by triangles. In this case, they're rectangles. Here they're big pentagons, and then here they're hexagons. So now I'm going to go ahead and we're going to do an example. So the first one is find the volume of each prism. In this case, it's again volume equals base times height. So the base is going to be this triangle. So if I were to find the area of the base, it's finding the area of a triangle. So it's 1/2 3 times 4 times the height, which is 2. But here I'm finding the base first, and then I'm going to go ahead and multiply it by the height. So 1/2 times 3 times 4 equals 6. The height is given to me, which is 2. And then I'm just going to go ahead and multiply both of those. So 6 times 2 equals 12 cubic centimeters. So do pay attention also to the units, as that is going to tell us what we are working with. So in this case, since we are talking about centimeters, then our answer will be in cubic centimeters, since we are talking about volume. And we are using 3 components. Okay, so now for this one, ideally this is something that you would be trying to do on your own. So this one's a little bit it requires a little bit more thinking. So we have this prism. We have the height, obviously it's a 5. Now they're giving us this portion here of the base, it's 6. So therefore I know this is 6. This is 3. And so I know that the whole thing is 14. So remember I'm just going to go ahead and do it on my phone so that you guys can see what I am talking about. Let's see. So again, the volume is equal to, actually, I'm going to go ahead and just give you the, go straight to the solution. Ideally, this would this slide is supposed to be an opportunity for you guys to kind of try it out on your own, and then it gives me a better idea just to see how advanced some of you guys are and whether or not I need to either slow it down a little bit or just keep going at this pace. So anyways, this is the solution, and so the part is find all the measures of the base first. So if this is 6, then I know this is 6. If they tell us that the whole thing is 14, then I know that, again, 6 plus what equals 14? 8. So I'm going to go ahead and divide the 8 by the 2 parts over here, which gives me 4, 4, 6, and then this is 3. So now all I need to do is find the area of this portion here, and I'm going to do that by parts. So it's finding the area of these 2 triangles here formed, and then finally this rectangle here. So I'm going to go ahead, in this case I have a half times 3 times 4 plus a half times 3 times 4 plus the 3 times the 6 here will give me the area of this rectangle. Then I go ahead and add all of those up, and I get that the base equals to 30. And then since the height is 5, then I'm just going to go ahead and multiply those 2 together. And let's see. Oops, went a little too far. Oh no, let's see. Then over here I would get that, you can't really see it here, but I would get that the volume equals the base times the height, which is 30 times 5, which equals to 150 cubic centimeters. Again, we have to be very mindful and aware of the measurements that we're working with. And so it would be, again, cubic because it's working with 3 different lengths, and it is in centimeters. Okay, so now we're going to go ahead and move on to the volume of a cylinder. Now it's the same thing, it's base times the height, but in this case, since we are working with a radius involved, then the base of the circle, actually, because it is a circle here, we're finding the area of the circle, which is pi r squared times the height. So you can still use it as use the volume equals base times height formula, or you can just remember that it's pi r squared h. Again, b is the area of the base, which is area of the circle, and we know what the area of the circle is pi r squared, and then the h is the height, and then the r is the radius of the base. So here we have an example, and it says find the volume of each cylinder. So we have that the radius is equal to 9, the height is equal to 6, so all we have to do is pretty much just plug it in. So we have volume equals pi r squared h. We're going to just leave the pi until the very end of our calculations. So I'm going to go ahead and just substitute everything in first, and then once I'm left with 46 pi in my calculator, I'm going to go ahead and use the pi button instead of 3.14, just so that you are as accurate as possible and you're not rounding anything. And then we're just going to round it to the nearest hundredths. So our answer would be about 1,526.81 cubic feet this time, because we are working with feet in this problem. Okay, so this would be a time for you guys to go ahead and explore this one on your own. So for example, I'm going to go ahead and try this one on my phone just so that you can see how it would work. And so we have the volume equals pi r squared h. So let's see, it would be, so again, let's see. Let's see. Okay, so I'm going to just leave it as an exact answer, but obviously you can see what I've done in this case from my phone. So I had, I know it's 4 pi r squared. The radius squared is 16, so I just go ahead and wrote 16 times the height times pi. I multiplied this and I got 112 pi. Obviously, depending on your teacher, they might want you to leave it as an exact form, so this would be perfectly fine. Or if they allowed you to do, again, round it off as it has been so far in the textbook, then we would go ahead and round it off. So here's the solution. Again, it's pretty much what I did, except now it just looks a little bit neater. And so we have that v equals pi r squared h. You're going to go ahead and plug these numbers in. And again, it's the same number that I got, 112 pi, but then when you use the pi function or button in your calculator, you're going to get 351.86 cubic centimeters, again, because we are working with centimeters in this problem. And so here's just a little social emotional learning aspect to this lesson. Drag your dot to how you're feeling. I just want to know how everyone's doing and whether I need to slow it down, whether I need to stop and reteach some things for the next lesson, or even now, like pausing and going over some of the parts that aren't as clear as I thought were going to be. But hopefully I would want to get all the dots here. Okay, so now we're moving on to using the formula for density. Now, density is the amount of matter that an object has in a given unit of volume. The density of an object is calculated by dividing its mass by its volume. If you remember from your physics class when you were in high school, or maybe it's something that you already know, it would be D equals dmv. That's how I remembered it. So it's density equals mass over volume. And so in this case, it says the diagram shows the dimensions of a standard gold bar at Fort Knox. Gold has a density of 19.3 grams per cubic centimeter. So they're giving us the density. Find the mass of a standard gold bar to the nearest gram. And so, yes, so these are the dimensions. So we're moving on to the very first step is we have to convert the dimensions to centimeters, because that's pretty much what we're using. We are using the metric system here. We're not going over on the inches. So we're going to go ahead and convert everything to centimeters. So for this, obviously, you'd be able to use your phones or your internet just so that you're able to find out exactly how many centimeters are in an inch, and then you would just go ahead and convert that. So for the length, we have 7 inches times, always the top is what you want, and then on the bottom is what's going to cancel out. So 2.54 centimeters over 1 inch will give you everything in centimeters. Same with this one. The width is 3.625 inches times 2.54 centimeters over 1 inch. You multiply those, the inches cancel, you get 9.2075. And then the height is 1.75 inches times 2.54 over 1 inch. And that gives you 4.445 centimeters. So now the next step is finding the volume. So the area of the base is 17.78 times 9.2075, which is equal to all of this. And the height is 4.445. So now all that's left is for us to multiply these, and we get about 727.69. Now it's all about using the density formula, which is D equals M over V. You're going to go ahead and substitute your values for these variables here, and you end up with 19.3 is about X over 727.69. You're going to go ahead and cross multiply, and you get X equals about 14,044 grams. Okay. So now we're moving on with using volumes of prisms and cylinders. So this one is modeling, it's a real life application and it's modeling with mathematics. This is obviously more for an advanced student, something that to challenge them. And so you're building a rectangular chest. You want the length to be 6 feet, the width to be 4 feet, and the volume to be 72 cubic feet. What should the height be? So obviously, also what I can see off the bat is I can multiply all of these, right? And then whatever that, so I would have 72 equals 6 times 4 times h, and then solve for h that way. Or I can do it this way where this is just a more step-by-step type of problem. So first is obviously the dimensions of the base of a rectangular prism and the volume. You're asked to find the height. We're going to be using the formula for the volume of a rectangular prism and then substitute the known variables or values, and solve for the height. So the area here of the base is 6 times 4, which is 24, and the volume is 72. So we're going to go ahead and do that, substitute that stuff in there, and then we get that the height is 3 feet. And then obviously we're going to go back and check our work by plugging everything back in and then making sure that we end up with our volume equals 72, which is what we did here. Volume equals the base times the height, which equals to 24 times 3, which equals to 72. Okay. This is another real life problem. So it says you're building a 6-foot tall dresser. You want the volume to be 36 cubic feet. What should the area of the base be? Give a possible length and width. So for this one, so we have the volume equals base times height. They give us the volume, which is 36. The base we don't know, and then the height is 6. Then all we do is divide both sides by 6, and I get that the base equals 6. So the area of the base should be 6 square feet. Now I have to think of dimensions that when I multiply them, I get 6. So the length could be a 3 and the width could be 2. Or it could also be where the length is, that's actually the only one. I was thinking 1 times 6, but that dimension would not work here, because it's just, if it was 6 across and then 1 this way, it would just be really, really not a natural dimension for this 6-foot tall dresser, and it wouldn't be very ideal for that. So in terms of just being realistic and solving a real life problem, then I think the length would have to be 3 and the width would have to be 2. But obviously those are just your own observations. Okay, so we're finally moving on to the last one. So the exit ticket question, and complete the sentence. Density is the amount of blank that an object has in a given unit of blank. So obviously I would leave it here, give you guys a few minutes to try and think about this one. We did go over it, not too in depth, but we would go back and just explain a little bit again before, so that the density is the amount of matter that an object has in a given unit of volume. So you can remember this as mass over volume. You can say mass or matter, it doesn't matter, over volume. So that's something that I would go ahead and go over. Just make sure that you're all doing okay. And one of the last reflections is pretty much, what did you like, what didn't you like, what was easy, and what was hard. So in the last, I've done this activity with my students before, and a lot of them, there were some who liked the entire thing. They liked the participation aspect, the engagement. Sometimes they gave me feedback that I was going a little bit too fast, and so they were they didn't have enough time to work on their problems, so I did try to slow down after that. And then what was easy, so obviously this depends on the person. And then what was hard, obviously I have already some ideas as to what I think might be hard, but then again, it's always not the case. So it's a really good way to just tell me, give me a quick feedback as to how this lesson went, and then what types of things I should go over for the following lesson without singling any student out and without making them feel like they're the only ones. So this was pretty much it. I hope you guys have a great day, and then I'll see you guys next time.